Following deposits are made in a fund at the beginning of each year. Fund earns annual effective 13%. At the end of 10th year, the fund is used to purchase a perpetuity immediate with semi-annual payments. The perpetuity earns annual effective 12%. Calculate X. So the deposits are not level deposits. They have different amounts. And we use their values at the end of the 10th year to purchase the perpetuity immediate. And so what we can do is to find the accumulated value of these deposits, we can just individually push every value to time 10. So we can tabulate these deposits. The first deposit was happening at year 0 because, look, it's a bit tricky. They're saying that they are having at the beginning of each year. So whatever is happening at the beginning of year 1 is actually happening at time 0, because time 0 is the beginning of year 1. Similarly, time 1 is the beginning of year 2. So here I have listed those years at which the deposits happen. So the first one happens at year 0, second one year 1, and so on. And we want their accumulated values at time 10, because that's when we purchase the perpetuity. So the first one, the deposit was 100. Its value at year 10 will be 100 times 1 plus I power 10. And these deposits are undergoing a 13% interest rate. Similarly, the second deposit happens at time 1, and it has 9 years to go up to year 10. So its value at year 10 will be 100 times 1.13 power 9. Third one is a deposit of 150, happens at year 2. So it sits for 8 years until time 10. So its value is 150 times 1.13 power 8, and similarly the other two. And the total accumulated value at time 10 is the sum of all these individual accumulated values. So you sum the last column, you get 1703.81. Now the perpetuity pays semi-annually, therefore we need the semi-annual effective rate J. So 1 plus I is equal to 1 plus I2 by 2 power 2. And I2 by 2, as you know, is the J. So now the perpetuity has an accompanying interest rate, which is different from the one for the deposits. The deposits, remember, were undergoing a 13% interest rate, but for the perpetuity, the interest rate, the annual effective interest rate is 12% and not 13%, as mentioned in the problem. And so J comes out to be 0.0583. And if we apply the perpetuity immediate formula, then the value of this perpetuity, so we are told that this is a perpetuity immediate. So immediately at the end of the 10th year, you find a perpetuity immediate, which means that actually these payments of the perpetuity start at time 11, because remember, a perpetuity immediate pays its first payment 1 period from the start, and the start here is like kind of 10 years, because that's when you purchase it. And so the first payment happens at time 11, but the present value formula for the perpetuity immediate gives the value 1 period before the first payment. So it will give you the value at time 10, and that's where the accumulation of the deposits was. So we can set the accumulated value of the deposits equal to the present value formula of the perpetuity immediate, X over J. J was 0.0583, so X comes out to be 99. That is choice A.